So in this way, with the help of this tabular form, we will come to know कि for each and every symbol, how that S of t is being represented and how to determine the magnitude as well as the desired phase angle for each and every symbol, which ranges from 0 0 0 towards the 1 1 1. Means as we are having the 8 different symbols, so for all these 8 different symbols with the unique assignments of these two level tables, those are being already discussed in that previous session, ki how to represent IC as well as QC bar, because IC is being produced by this upper channel and QC bar is being produced by that lower channel. So simply we need to put the relevant values of this IC, because this IC is being superimposed with the help of the sine carrier and QC bar is being superimposed over the cos carrier. So we are supposed to consider the desired values, those are being assigned, and in this way that whole table is being completed. Because for what purpose we are doing all these things? In order to represent the constellation diagram, right? So let us quickly go through the constellation diagram for this M-Ary phase shift keying technique, right? So as you can see, so to complete the constellation diagram for this 8 array phase shift keying technique based upon these 8 different symbols along with their magnitude and the desired phase value, let us assign this sine carrier sin omega ct and here cos carrier cos omega ct. So obviously it will become minus sin omega ct by the virtue of this 90 degree, and by the virtue of this 90 degree it will become minus cos of omega ct, right? So let us quickly go through the first symbol, how it is being represented with this negative sine carrier and the negative cos carrier. So we need to look around that in which particular quadrant we used to have the negative value of this sine carrier and the negative value of this cos carrier, right? So we are coming on to this conclusion ki within this third quadrant we do have the negative values of this sine carrier as well as cos carrier, right? And their magnitude of each and every symbol is exactly equals to root 2, right? And the phase angle for this symbol is exactly equals to 67.51, right? So when I draw this such type of vector within this third quadrant, right? So it is used to represent which symbol 3 times 0, right? So in this way this 0 0 0 is being represented with this desired phase angle of 67.51. Similarly, the second symbol, in that second symbol again one more time we used to have the negative sign as well as negative cos carrier, right? So again within that third quadrant if I draw another vector, so which is to be represented with this symbol which is nothing but what 0 0 1, whose phase angle will be 22.48. magnitude is just exactly similar to the previous one, or the magnitude for each and every symbol is exactly equals to root 2, right? Simply their phase angles are being varied according to the desired quadrant, right? So in this way these two symbols are being represented, first two symbols. So ultimately the third, within that third symbol which is nothing but what 0 1 0, here sign is positive and cosine pattern is nothing but what negative. So which quadrant we need to look around? The quadrant in which the sign is positive and cosine is negative, right? So this is the fourth quadrant. The sign is positive and cosine carrier is negative. So which symbol it is? It is 0 1 0, whose desired phase value is exactly equals to minus 67.51. Similarly, within that fourth symbol also we need to look around to the same quadrant, because sine is positive and cos is negative. So which symbol is being represented? 0 1 1, right? So it will become 0 1 1, whose phase angle is exactly equals to how much here? 0 1 1, it is minus 22.48. Similarly, the symbol number 5 is nothing but what? 1 0 0, in which the sine term is negative and the cosine term is positive. So we need to look around to that particular quadrant in which the sine is negative and the cos is positive. So definitely we will come on to this conclusion ki we need to follow the second quadrant, right? So when I draw this vector, so which is represented by this symbol, that is nothing but what? 1 0 0, right? Whose phase angle is exactly equals to how much it is? Minus 67.51, right? Similarly, the symbol number 6, again the sign is negative and the cos is positive. So again sign is negative and cos is positive. So within that same quadrant, if I draw the another vector here, which is used to represent the symbol number 6, that is nothing but what? 1 0 1. Here I will put all those symbols within this opening and closing parenthesis like this. So we can understand the desired phase angle. So the phase angle is how much here? It is minus 22.48. Similarly, the next symbol is nothing but 110 and 111. Within these two symbols, the sine term is positive as well as the cos term is also positive, right? So we need to look around to the first quadrant in which the sine is also positive and the cos is also positive, right? So first vector is used to represent 110 and the last vector is being used to represent 111 and 3 times 1, right? With their respective phase angles, those are nothing but 67.51 and 22.48, right? So in this way, this constellation diagram is to be drawn for this 8 array phase shift keying technique. Instead of that, we can vary that number of symbols to the mth level. So instead of that 8, we can have the 16, 32 like this, right? But the strategy remains same, right? Only the levels are being enhanced, right? So in this way, this 8 array PSK works. Now in that remaining session, we will try to discuss the demodulator or the receiver belongs to this 8 array PSK technique. Okay friends, so this is how the 8 array demodulator or the receiver will look like. As far as this existing receiver is concerned, which works in same manner as compared to the quadrature phase shift keying technique, which we had discussed in earlier session, right? So first of all, here the modulating symbol sequence is being given to the first block is nothing but what? The power level of this received symbol sequence is being raised by an amount of m factor, because see, our ultimate aim in case of this demodulation is to demodulate the desired carrier signal from that received symbol sequence, right? So in order to regenerate this coherent carrier, because this is nothing but what? The coherent type of detector which adopts the same carrier frequency which was used by that 8 array PSK modulator, right? So these two coherent carriers are nothing but what? The sine carrier as well as cosine carrier. To regenerate these two carriers, first of all, the power level of this received symbol sequence, that is nothing but what? S of t. So how to get this S of t? Because already we had discussed this S of t is nothing but what? IC into cos of omega ct plus QC bar into sine of omega ct. Sorry, here IC into the first carrier is nothing but what? Sine of omega ct, and QC bar is being superimposed on this cos carrier, cos omega ct, right? So our aim is to, first of all, we need to regenerate these two coherent carrier frequencies. So for that purpose, after being passed through this power level enhancer, it is being given to the BPF, stands for what? The band pass filter. So it is being tuned to that frequency which exactly equals to m times of f0, right? So which will try to eliminate or which will try to suppress all the frequency component apart from this particular band of frequency, right? Then once it is being passed through this frequency divider network, which will try to regenerate the sine and cosine carriers, because these two sine and cosine or these two coherent carriers are being given to the two identical channel, upper one and the lower one, right? In order to reconstruct the original symbol sequence which was given to the 8 array phase shift keying modulator or the transmitter. So finally, this binary symbol sequence which was given to one of the input of this 8 array PSK modulator or the transmitter is being regenerated. So that is our objective, right? So as you can see, correlator stands for what? Which consists of the signal multiplier along with this integrator, right? So these two signal multiplier, again, which consists of two identical input, one is digital or one is modulating or the demodulating symbol sequence, and the second one is nothing but what? The coherent carrier, right? So this sine carrier is being given to the upper modulator and the cos carrier is being given to the lower modulator. The remaining two inputs of these modulators are nothing but what? The demodulated symbol sequence, right? which is to be given by these S of t stands for what, the received symbol sequence, right? So as you can see, in this way this modulator will work. So this two modulator will try to suppress these two coherent carriers, sine and cosine, right? Once it is being suppressed, it is being given to this integrator, right? So basically this integrator will try to integrate this multiplied or the suppressed symbol sequence over the interval Ts is equal to n times of Tb, right? Or we can say that m times of Tb, because as we are having the m number of symbols and the bit Tb stands for what, the bit duration for each and every binary one as well as 0. So the bit duration for each and every symbol, right? So once it is being integrated over this sampling interval, because after these two integrator, which identical block we used to have, because demodulator means what, which works in opposite manner as compared to modulator. So in case of this just we had discussed 8-array PSK modulator, we used to have the digital to analog converter block, right? Belongs to upper channel as well as lower channel, right? So here we should include this analog to digital converter, because our aim is to reconstruct the binary symbol sequence, right? So this ADC is being connected after these two correlators, right? So after this correlator, the output of integrator is being sampled, where the desired time space in between any two successive sample is exactly equals to Ts second, right? So by taking into account this desired sampling interval, it is being sampled and it is being given to analog to digital converter. And what will be the output of this analog to digital converter block? The n number of bits are being emitted by this analog to digital converter, which are being collected by this. Finally, which block we are having with us? The parallel to serial converter, right? So all these parallel bits are being converted into the single serial bit stream signal, and finally we can extract the desired binary symbol sequence, which is being given to the input of this modulator, right? So this is how this M-Ary modulator and demodulator works, or the transmitter and receiver works. One more time we need to remember what was our objective behind this study is to improve the transmission bandwidth, because the bandwidth efficiency is one of the most important factor while designing such type of digital modulators. Thank you.